Hello, everybody. Welcome back to this channel. Thank you very much for joining us once again. And today we're going to be doing finance for your November 2022. And that's your question 6. Okay, let's go. Okay, 6.1. We are given that 12,000 is invested in a fund that paid the interest at M% per annum, compounded quarterly. Okay, so so let me just highlight this. After 24 months, the value of the investment was 13,459. Okay, then the question wants us to get the value of M. Okay, so we do know that this is compound interest, as the money is gaining interest that are compounded. Okay, so the formula for compound interest, that's it, where A stands for the accumulated amount after the investment. So the amount reached 13,459. Then P represents the amount that was deposited or invested, which is what? 12,000. Okay, 1 plus. We do understand that our interest is now represented as M%, right? Which is compounded monthly. So our interest is M, and this is compounded sorry, not monthly, quarterly. Okay, so if it's compounded quarterly, we do know that in a year we have 4 quarters, then we have to divide by 4. Okay, so then in our number of years, remember N represents the number of years, but this must be compounded quarterly, they must be in quarters. So we are given 24 months, right, which is the same as what? As 2 years, right? And in 2 years, how many quarters do we have? In 1 year, we only have 4 quarters. In 2 years, we'll actually have 4 plus 4, which is 8 quarters, right? Or someone can choose to say, okay, it's 2 years multiplied by the compounding period, which is 4, which is going to give you 8. Okay, so now we can go and solve for M. How do we solve for M? It's just simply algebra there. Can divide both sides by 12,000. Then you have 13,459 divided by 12,000. That is if we are dividing both sides by what? By 12,000. Okay, so that 12,000 and 12,000 cancels there. Okay, then we have like this, 1 plus M over 4 exponent 8. How can we get rid of that exponent 8? By applying the what? The 8th root both sides. Okay, because we'll know it will be the same as 8 over 8 in the exponent, which will cancel that exponent. Okay, so we are left with, let me just punch my calculator on the left hand side. We have the 8th root of 13,459 divided by 12,000, which is giving me 1.0144. Okay, so this side will have 1 plus M over 4. We want to solve for M. We're going to transpose 1. We take 1 to the other side to be minus 1. Then we have 0.0144 is equals to M over 4. To solve for M, obviously, we'll multiply by 4 both sides. Okay, so we multiply this by 4. Then when we multiply by 4, we are getting M is equals to 0.0578. Okay, 0.0578. Okay, so that is our value of M. But remember, but M is in percentage, so we can also multiply this by what? By 100, so that we convert it into being M%. So our M will finally be what? Will finally be 5.78%. So that's our value of M. All right, let's now go to 6.2. They are saying on the 31st of Jan 2022, Tino deposited 1,000 into an account that paid an interest of 7.5% per annum, which was compounded monthly. All right, so he continued depositing 1,000 on the last day of every month, right? So this is a regular payment. And on the last day, he was making payments of 1,000 31st Jan, 1,030 Feb, is it 28 Feb, 1,000 like that, 31 April like that, 1,000. Okay, he will make his last deposit on the 31st December 2022. Then the question says, will Tino have sufficient funds in the account on the 1st of Jan 2023 to buy a computer that costs 13,000 rands? Justify your answer by means of appropriate calculation. Okay, so as opposed to the previous question 6.1, where we're just dealing with just a once-off deposit and you wait for your money, that was just compound interest, right? But now you can see that if someone is making regular payments, okay, regular payments to buy something at the end, you want to buy a computer, then we have to talk about an annuity, more especially future value annuity, okay, because payments are being made regularly, and the person is making fixed payments at the end of every month, is putting 1,000 1,000 1,000. So that would be an annuity. Okay, so specifically future value annuity. So we want to know the future value of this person so that we can be able to compare it with the 13,000 to see if it's more than 13,000 or less than 13,000, so that we can justify our explanation. Okay, so now we do know we are dealing with a future value annuity, and the formula says x into 1 plus I exponent n minus 1 divided by I. Okay, where x represents the number of regular payments that you are making. Obviously in this case is what the person is paying 1,000, right? Then what is the interest? 7.5 in decimal, 0.075. This is compounded monthly. In a year we have 12 months. Then n, right, the number of payments. Remember, in this case it does not stand for the number of years, but rather the number of payments that the person is making. So the payment was made from the 31st Jan, and it will be made every month, at the end of every month thereafter, until the last deposit. He will make it on 31st December. Okay, so you can see that the number of payment that will be made, if you just put it in a timeline and count, it will be what? It will be 12 payments. Okay, so that is your n minus 1 divided by 0.075, then divided by what? Divided by 12. Okay, so now we can calculate the future value of this amount, okay, of this fixed deposit. Okay, when you just press your calculator, it's going to give us 12,421.22, and this is the future value. We can answer the question on the 1st of Jan, right? Remember, this is the money that will be in the account exactly on the 31st, right? After the 31st, we do know that there's going to be, obviously we go to 1 Jan. So the next day, obviously the person will still have 12,421.22, right? Then will it be enough to buy a computer that costs 13,000? Obviously the answer is what? It's no. The amount won't be enough, because 12,000 is actually 12,421.22 is less than the price of the computer, which is 13,000. Okay. It says Tabo plans to buy a car that costs 250,000 rands. He's going to pay a deposit of 15%, right? And he's going to take out a loan for the remaining balance, right? So the interest on the loan is 13% per annum compounded monthly. And the first one, 6.3.1. They want you to calculate the value of the loan that he must take. Hence, it's only 1 mark, right? We know that 15% of this 250,000 went to the deposit, right? So obviously, out of 100%, 85%, if we take out 15%, we'll be left with 85%. That's the amount that he must borrow, right? So basically, someone might want to take the long approach, you say, okay, I'm just actually gonna first calculate the amount that went to the deposit, which is 15%. Okay, then you find the answer. So 250,000 multiplied by 15%, it's giving me 37,500. So this is the money that went to the deposit. Okay, so from the 250,000, we want to know how much is the loan. So we are subtracting the amount that went to the deposit to say how much did he now request as his loan in order to pay up the car. So he will request 212,500 rands. Okay, so basically someone so this is the value of the loan that is going to take, the present value. Okay, because 15 went to the deposit. Someone might choose to say, okay, actually we do know that 15% went to the deposit. It means that the loan of will be only 85% of this amount. In a way, we say 100 minus 15, which is 85. So because 15 went to the deposit, it means 85% of this money will go towards the towards the loan that the person will request. Okay, so then you punch your calculator, you still get the same answer. Okay, let's go to 6.3.2. All right, 6.3.2, they are saying the first repayment will be made 6 months after the loan has been granted. Remember, the person only paid 15%, right? Then we find that he has to take a loan of 212,500 rands. So they are saying this person will start repaying back this loan after what? After 6 months, after the loan has been granted. The loan will be repaid over a period of 6 years after it has been granted. Calculate the monthly installments. Okay, calculate the monthly installments. So you can see that this is a present value annuity because we are dealing with a person who has gone to a bank or something to loan this 212,500, right? So obviously the formula we have to use is present value is equals to x into 1 minus 1 plus I exponent minus n divided by I. But remember, we are looking for the monthly installments, right, which is x. So if we divide both sides by this big bracket here, you will get that your x is equals to present value divided by 1 minus 1 plus I exponent minus n over I. Okay, so now what is the loan now, right? Remember, if you go and take a loan, right, they only allow you to start paying after 1 month, right? It doesn't make sense if I go and loan today and they expect me to start paying tomorrow, right? So what they normally do, the normal condition is that if I take a loan, they give me 1 month, then thereafter I have to pay after a month, right? After a month has passed. So in this case, you find that the person only start making their first repayment after 6 months. Okay, so what is going to happen is that, okay, the loan that you took, 212,500, it's actually gonna gain interest because themselves they are saying, okay, we do allow you after 1 month you may not pay, but you have to start paying you have to start paying after 1 month. So the first month they do allow you, the rest your loan start gaining interest if you don't make the payment. So obviously 6 months has passed, so his loan is only gonna grow with what? With 5 months, because the first month is the normal condition you are allowed, you have to start paying after 1 month. So after the first month they do allow, but then if you don't make the payment in the second month, your loan start gaining the interest thereafter, like that. So it will only gain interest for how long? For 5 months. So it will be compounded. So basically our present value, maybe I'm just gonna put it here in the formula, that our 212,500 is gonna gain interest. It's going to gain this compound interest, which is 13%. 0.13 is compounded monthly divided by 12 for how many? For 5 months, because the first month is the normal condition, right? As you can't start paying immediately and stuff. The first month they do allow, but if you spend 6 months now, they will charge you. Your loan will never be the same. It will gain some interest for a period of 5 months because the person took 6 months in this case. Okay. Then this is going to be divided by 1 minus 1 plus, what is our interest? This is 13%, which is 0.13 compounded monthly divided by 12. And this has to be repaid over a period of what? Of 6 years. Okay. So it's still going to be, it's negative 6 multiplied by, this is compounded monthly. So we multiply by 12. So 0.13 divided by 12. Okay, you might want to do this separately to first show that actually the loan will now grow, and you put the value separately, and then you just put everything together. Then you can just simply punch your calculator and get the final answer for that. Okay, I think that's all for finance. All right.